chapter 2 polynomials, where we can see the introduction into polynomials, prerequisites for exercise 2.1 and solutions to exercise 2.1. What is a polynomial in one variable? A polynomial in one variable x of degree n. It is nothing but an expression of the form a n x to the power of n plus a n minus 1 x to the power of n minus 1 and so on up to a0, where all these a0, a1, a2 and so on up to an are constants and an is not equal to 0. What we mean by an not equal to 0 is if we replace 0 in the above given polynomial, the entire phrase of the term x to the power of n becomes 0. Thereby, the degree of the polynomial will not be equal to n. So, in order for a polynomial to have a degree of n, we should see to that an is not equal to 0. So, a polynomial in one variable is an algebraic expression which is expressed in terms of only one variable. Not more than one variable will exist in this polynomial in one variable. But with multiple variables also, polynomials can exist. What are the components of a polynomial? It can consist of variables like x, y, t, etc. Coefficients. What are coefficients? They are the numbers or constants. If you look into the polynomial mentioned in the first line, the coefficients are an minus 1, a1, etc. Variables. They are represented by alphabets. In the polynomial, it is the variable that is being used is x. Exponents, whole numbers. These exponents in a polynomial can only be whole numbers. Only the non-negative integers. Say for example, if x to the power of 2 by 3 or x to the power of minus 1, they are not included in a polynomial. If you find any such variable in a polynomial, we say it is not a polynomial. Why? The exponent, that is the power raised to x, should always be a whole number, a non-negative integer. Now let's look into what are called as terms, the individual parts in a polynomial which is separated by the mathematical operators like plus, minus, divide, etc. So look at the examples. So the first one is a polynomial in a variable x. The second one is a polynomial in variable y. The third one is a polynomial in variable t. As you can see, these polynomials are expressed in only one variable. Each one of it contains only one variable. The variable as such could be anything like x, y or t. But one polynomial has only one variable. Let's look into the components of a polynomial. Say for example, we consider a polynomial minus x cubed plus 4x squared plus 7x minus 2. This is a polynomial in variable x. What do we define by the coefficient? It is nothing but a numerical or a constant quantity placed before and multiplying the variable in each term. So, if we look into the number of terms, how many terms this particular polynomial has? It has got 4 terms. So, the terms are minus x to the power of 3, 4x squared, 7x and minus 2. These are the 4 terms in this particular polynomial. So, what do we mean by coefficient is the number which is getting multiplied with the variable mentioned in the polynomial under each and every term. So, for the first term, the coefficient becomes minus 1. For the second term, 4x squared, it becomes 4. 7x. What is the coefficient? It is 7. And for minus 2, it is considered to be a constant. It is a coefficient of x to the power of 0. Anything to the power of 0 is 1. So, 2 times x to the power of 0 makes it a constant number. For this polynomial, it is minus 2. What are variables? Variables are denoted by the letter or symbol representing any real value. The variable can have values like when you represent values for the variables in a polynomial, it can take in values like 1 by 2, minus 6, 0, etc. But the variable by itself cannot be represented as 1 by x or square root of x, etc. Why? Because of the concept of exponents, which we will be looking into very shortly. So what is an exponent? The power to which the variable is raised. There is a condition that in a polynomial, the exponent can only be whole numbers starting from 0 and so on, and many other numbers. And we exclude the other types of real numbers like half, minus 6, 0. So because of this reason, the variable cannot exist as 1 by x or root x, etc. What is a constant? It is the term without a variable representing a fixed value. Why do we say like that? It is nothing but the coefficient of x to the power of 0, which means the constant multiplied by 1 remains a constant number by itself. So that particular number in the polynomial is called a constant. Let's look into some interesting facts on polynomials. Do you know that 5 is also a polynomial? Yes, it is a polynomial. Only the number 5. It is called a constant polynomial. Any fixed numbers can be called a constant polynomial, the exception being 0. If 0 is to be called a polynomial, it is called a zero polynomial. So for questions like is 250 a polynomial, is 0 a polynomial, is minus 45 a polynomial, the answer is true. Now, how do we denote polynomials? Suppose we have a polynomial in variable z. Then we denote the polynomial as f of z or g of z or r of z, etc. Given below are three such examples of how we can denote the polynomials. How many maximum terms can any polynomial have? A polynomial can have finite number of terms. It cannot have infinite number of terms. All these will be helpful in answering the true or false question. Looking at the screen, you can understand how a polynomial is classified based on what? Based on the number of terms, it is divided into a monomial or a binomial or a trinomial or a polynomial. Based on the degree also, the polynomials can be classified into constant when the degree is 0, a zero polynomial when the degree is not defined. When the polynomial itself is equal to 0, then the degree of it is not defined. And the third one is a linear polynomial when the degree is 1, quadratic when the degree is 2, cubic when the degree is 3. We can look into these explanations of the number of terms and the degrees in the subsequent slides. How do we define the degree of a polynomial? It is the highest power of whichever variable is there in the polynomial. The classification based on the degree, it's constant, zero, linear, quadratic and cubic. Let's look into the definitions of each one of them. Constant has only the constant numbers. If the polynomial itself is 0, then it is called a zero polynomial and the degree of which is not defined. Linear, the power of the expression, the maximum degree is 1. Quadratic, the maximum degree is 2. And cubic, the maximum degree is 3. Look into the facts of each one of these, like the coefficient of x should not be equal to 0 in linear. The coefficient of x squared should not be equal to 0 in case of quadratic. Of x cubed should not be equal to 0 in case of cubic. Let's look into some sample polynomials. I have segregated into the monomial, binomial and trinomial depending on how many terms each of the polynomial has. So the degree of 2x is 1, the degree of 2 is 0. Why? It is just the 2 is just a coefficient of x to the power of 0. So there is only one variable with a power of 0. So the degree of 2 is 1. This is called a non-zero constant polynomial. If you look into the last case, the degree of 0 is not defined. It itself is called a zero polynomial. There is a difference between zero polynomial and constant polynomial. For the binomials, you can see very well there are two terms in each of these polynomials. The maximum degree could be anything, but identify the maximum degree and that happens to be the degree of the polynomial or the binomial. For the trinomial, there are three terms. For the last polynomial, y to the power of 4 plus y plus 5, there are three terms. So it is a trinomial, the degree of which is 4. Let's look into the exercise problems. Which of the following expressions are polynomials in one variable and which are not? The first one is a polynomial in one variable x. There is only one variable x in the polynomial. So it satisfies the question. Y squared plus root 2. Yes, it is a polynomial. There is only one variable which is y. Now 3 root 2 plus 3 root t plus t root 2. It can be written. How can it be rewritten? It is nothing but 3 to the 3 t to the power of half plus t root 2. If you look into the variables, t cannot have an exponent which is other than a whole number. Here it is a it's a fraction 1 by 2. So this kind is not allowed in a polynomial. So this expression is not a polynomial. The next one is y plus 2 by y. It can be rewritten as y plus 2y to the power of minus 1. What are the exponents here? 1 and minus 1. Minus 1 is not a whole number, so the expression is not a polynomial by itself. The last one is x to the power of 10 plus y cube plus t to the power of 50. How many terms are there? There are three terms, but the question is, which of the following expressions are polynomials in one variable? Here there are three variables. It doesn't satisfy the condition. It's a very simple. Write the coefficients of x squared in each of the following. Just identify x squared, the number that x squared is multiplied with in any of the terms will be the coefficient. So if you look into the sum number 3, pi by 2 is the coefficient of x squared. For the last sum, there is nothing like x to the x squared. So what do we say? The coefficient of x squared is 0. Only when you multiply 0 with x squared, the entire term becomes 0. There is no such term as x squared. So for sums like this, the coefficient of x squared is 0. The next sum is give one example each of a binomial of degree 35 and of a monomial of degree 100. Binomial meaning there should definitely be two terms. Of degree 35, the maximum degree the maximum exponent value is 35, making the degree of the polynomial 35. The next one is a monomial of degree 100. Monomial meaning there should be only one term in the entire polynomial or the monomial of degree 100. So there is only one term which has a variable raised to the exponent 100, which answers to this question. The next one, write the degree of each of the following polynomials. The highest one, highest exponent is the degree. For the first one is 3, we can make out variable. For the second one is 2. For the third one is 1. For the fourth one, there is no variable, meaning a variable raised to 0. So it is 0. The highest degree is 0. Let's classify the following as linear, quadratic and cubic polynomials. So if the highest exponent of the polynomial is 1, then it's a linear polynomial. If it is 2, it's quadratic. If it is 3, it is cubic. So the first one, what is the degree? It is 2. So quadratic. Second one is 3. So it's a cubic. Third one is 2. Quadratic. Fourth one is 1. Linear. Fifth one is also 1. Linear. Sixth one is 2. It's a quadratic. Seventh one is 3. Hence it's a cubic.